Like those would be solutions. They would come after you figured the problem out, after you spell the problem out. Do you agree with this? This is like the prerequisite for any inspect and adapt, right? And that's very interesting. The other interesting thing is that whenever you inspect and adapt, like really for a long time, you will find out it's very hard to estimate the effect before you start doing it. But you start doing it and all of a sudden things like magically happen that were completely unpredictable before you really started, right? So this is why in those situations, right, this kind of replaces the idea that a decision must be made always by knowing exactly what the consequences are. Right? Rather than when you're in inspect and adapt, you start by saying, this is a problem, and I know that once I make the problem explicit, afterwards, I will just inspect and adapt on it, and I know that in, let's say, 6 months, 1 year, 2 years, I will be in a much, much more better place because I made the problem explicit. Right? And then the question is, we do not necessarily choose to focus on a problem because it's profitable. We choose to focus on a problem because it's a principle. Some principle is violated, or some principle tells us to do it. Right? That's the interesting thing about inspect that. Do you agree? Okay.
I mean, people are that as you're expecting out in Europe, then like discovering what those principles are, as you put those principles in the question.
Sometimes you put principles into question, right? But that's another principle. But the point is that you do not choose to go in this direction or that direction only because you know the outcome. Because most of the time you don't know the outcome. You just know how it feels before, right? You know that something maybe is wrong, and then you choose to focus, to invest time to fix that thing. You don't know what the end solution will be, so now we select for you, but maybe, I don't know, in a few weeks, it will be email, or maybe it will be something else, right, that you will find along the way. So you don't know exactly what that solution will be, you just know that this problem, you don't want the problem to appear again. And then what you do evaluate is not the, you will evaluate to see, is the nature of the problem the same? Or has it changed a long time, right? This is how you measure progress, let's say.
Okay, it's not so easy to find the root cause.
It's not so easy to find the root cause, but once you do find the root cause, that's the most exciting thing. Because symptoms, that's not necessarily interesting, right? Symptoms tell you there's a problem here, but it doesn't tell you how to solve it. So finding that root cause, that's the most interesting thing. And that's a principle that you want to go and follow all the time. So that's why I love being here, because you already understand this, because you're living this on a daily basis, right? Okay. So I'm gonna just ask you a couple of questions. This one question: do you agree that developers spend, let's say, 50% or more of their time reading code? Yeah. Would you? Yeah. Or? What? 80%, so more, right? But 50% or more. Would you agree with this?
Depends on company. Depends on company.
Depends on the?
On the company.
On the company.
On the company. No, but you, like for example, in your case,
sure, right.
is it like this? Huh? So I actually asked several thousand developers just in the last couple of years, and they kind of pretty much everybody agrees that this is the case. 50% also happens to mean, or more, happens to be the single largest, most expensive thing. That's what it means. Right? Now, another question. So when was the last time you talked about how you read code?
Never, because we read the code from left to right.
So left to right, exactly. Top to bottom, left to right.
What's to discuss
Actually, no,
about?
we don't. I mean, one of the things that I love about having an IDE is that I can easily read and navigate through code. So,
I understand, but my question is again, have you talked about how you read code?
I mean,
you should. We need.
No.
I mean,
No, right? Yes, go ahead.
I mean, we have discussed this sometime. for instance, what do you start? Do you start if the code has tests? Do you start from I read it and then you go to implementation, or the other way around?
Right.
Or things
Is
like
it the norm? Is it like, does it happen often, this conversation?
not often,
But you also had some, maybe in the back, you wanted to say
No,
something?
I mean, it happens once, maybe twice.
Right, but
I
it's
mean,
not
but
like
it was just a side discussion
Yeah, side
from
discussion,
some other.
yeah,
from
okay,
different
interesting.
topic.
I mean, I think it's a conversation you must have with junior developers.
With junior developers, because senior developers already know how to read code, right?
I'm not sure if they agree now, but I think that in my experience, most of the conversations don't revolve solely about reading code, but instead of how to write code and documentation that helps the next developer read that code.
I understand, but my question is,
Yes.
this is about the writing thing. Now, let's just put it again in perspective, right? So the thing is, when we think about software development, right, we talk about the active part. That is, I don't have it, I build it, and then I have it, right? That's what we talk about. So essentially, we look at software engineering as a construction business, right? Right. But it turns out that you spend most of your time not building anything. So coming back to this idea of inspect and adapt, before you can optimize anything, you first have to make it explicit. We agreed on that, right?
Yep.
Yeah.
Okay, so let me put this one again in perspective. This is a budget you have. You don't ask for anybody because you already have it. It's what you spend your time. I mean, every one of you spends this time the way you choose to. This is not about asking for somebody's, permission to do something else. You choose to spend it, right? Okay. So, do you agree to talk about it? At least to start that conversation, right? Okay. So let's see. Why do you read code?
Why?
Yeah. Again, like if
Because I'm bored.
Because you're right?
Well,
But you're a
To learn-
manager, so it doesn't count.
To learn different ways, about to learn different ways to do it, maybe the things that we guess we know to do it in different way.
To learn to do this, is this what you do on a daily basis? To learn different ways?
Different ways to do the thing.
Most of the time to change it.
Yeah.
yeah, I
Most
mean,
of them?
Maybe
I would
either
say-
to change it or to build on top of that, right?
Yeah.
Because I need to understand the basics where I'm building from.
Right. So the goal isn't to read. I mean, it's not like reading Harry Potter, is it?
Yeah.
Who likes Harry Potter? Who doesn't like Harry Potter? Really?
Right. I mean,
Okay, anyway. But it's not the same thing, right? You read it with a very, very clear purpose. And that purpose is the thing that you do before you act. Right? Is that the goal, right?
To learn.
To understand, because you want to build on top of that
To
sometimes.
understand, but it's not to understand.
For me, I think that it's to understand.
Is
what
it
you did
enough?
before.
As I said, like I, for example, if you read Plato or Socrates or whatever, you pick your favorite philosopher, that will teach you to understand that you don't read code in the same way.
I mean,
There's a very clear point, right? You understand enough to make a change, right? It's not the same thing. It's not getting the understanding. Understand enough to make a change. Yes.
Beyond the thing that you read the code, maybe because you're working on that, I guess also is, in fact, you read code sometimes to learn maybe something or some API or something that
This
you,
is true.
maybe a new technique or maybe new way
Right,
to do
but
it.
this is not what you do. You do this. You read code to learn.
Yeah.
Like novices, for example, this is how they learn. But that's not what occupies most of your time.
No,
Most of
you're
your
right.
time,
You're right.
It is spent, right? We're talking about the bulk of this time.
Okay, right.
I think that a lot of time, I mean, I don't think maybe 50% of my time, but a lot of time I should read code to understand the behavior of the system and what happened. For
Exactly, and
example,
then
for example, for a production someone asks you, hey, this happened, and you start system saw this happened, and maybe I read the logs, I read the code, and I say, well, this is what happened, and this is how the system behaved, and maybe I can change the thing.
Right.
Then I read in order to say the history of what happened.
Exactly.
And you do
And
that,
then
and
usually it is useful because you want to know what to act, how to act in the next step,
yeah,
right?
maybe I won't change anything, or maybe I will.
Exactly. But we call it in some, there is a word associated with that, and that word is called decision. So you spend this time to make decisions. That's your goal. But the reason you spend the effort is that you understand enough to make the decision.
Yeah.
Right? Well, this kind of qualifies us. Like if you can look at it as a construction business, software engineering, but you can equally look at the software engineering as being a decision-making business. Isn't it? It's just being consequential. Okay, but this also means that reading isn't the activity. Reading is just the way you accumulate information so that you inform the decision. Isn't it? Right? So if reading is a solution, what did we learn before? Once we have a problem, there could be another solution. No? But you first have to entertain the possibility before you can find what that solution can be. Do we agree with this? Right?
Maybe.
What is maybe?
No, I mean, I understand in principle.
No, but I'm saying, just
I'm
saying.
just worrying, I'm just thinking, how could there be an alternative solution?
How could there be an alternative solution? But again, we said before, inspect and adapt. You don't know where you will be before you start doing it. And you're doing it because of a principle. And now we're just saying, well, you're not optimizing because you never talk about it. Half, let me say it again, half of your budget. That's a lot of budget. It basically means, what if you could do this one, 10 times faster? It basically means you could go home at 1 o'clock. But it's not a joke. It's a real thing.
Make me laugh anyway.
Yeah. So, right now, once you make it, so this is the direct cost that we look at decision making. The real interesting costs are actually these ones. No? Because once you do make a decision, then that one actually has real implications once you change the system. Now, what if you didn't make the decisions with all the information in your head? What if you didn't take all the information into account when you made the decision? The decision might have been right with the information that you had at the time, but they were not complete, the information. It's possible, right? So it's worthwhile thinking about it, right? Not just the direct costs, but the real costs are actually the indirect costs. Now let's talk about it. So I hear that you have an interesting, anybody here from that famous Ruby system that you're maintaining?
That we are maintaining.
Yeah, you're evolving, sorry, the legacy thing. No, which one? Excellent. So get to the point. How many of you are working with legacy systems? So how many of you, okay, excellent, like half of you. How many of you love working with legacy systems? Love working with legacy systems. Nobody?
I won't. Before you ask the question,
Nobody.
I mean, before you ask the question, I wouldn't have thought that I love working on a system, but all the time I come to.
You love it sometimes.
Maybe.
When you go home.
I think he
No.
enjoyed it.
Right.
No, actually, it depends on the system.
I see. Okay, but see, think about it, right? That's for me, it's mind-bogglingly crazy. Programming is supposed to be the coolest job on the planet, right? You're here, you have the coolest job on the planet. And yet you spend most of your time disliking your job. I mean, that is worth investigating, don't you think? I mean, if you were annoyed by being late for 2 minutes, wouldn't you love to just spend more time thinking about how you could get happier? Right? I think it's worthwhile. Anyway, so now we spent such a long introduction to tell you why this is important. So the one thing that I want to get out of this presentation is this. I want you to start talking about how you read code. And I just want to give you the arguments as to why that conversation is worthwhile. Not just why it's a problem, but what are the potential alternatives. Okay? That's the talk of today. Because you're not reading code. You're doing something such that you can make decisions about how to change your system. And I call that thing, it was like with Voldemort, those that have read or listened to Harry Potter, right? Voldemort,
Yeah.
right? He didn't want people to name him because it was like naming him it was the prerequisite for being able to fight him, right? So that's why we shouldn't leave this one unnamed. So I give you the name, and I call it assessment. So assessment is the discipline of understanding a system enough, a situation about a system enough to make a decision. The key here is not the time you spend understanding, the key here is the quality of the decision that you make. Okay, so quick question. Let's say if you have 250,000 lines of code. Do you think that's a large Java system, for example?
Yeah.
250,000 lines of code. Is that a large Java system? Like a medium, right? Medium. It's not something that you have never seen, right? Okay. How long would it take you to read it?
Depends.
Depends on the complexity.
No, to read it. To read it.
To complete completely.
Completely. Exactly.
It will take years.
No, let's say that you do. Let's do a math. Let's do the math, right? Let's say you read really fast, like really fast, 1 line in 2 seconds. That's significantly fast. Let's say you can keep this speed for 8 hours per day. It takes you a person month of work. Okay? This is how much time it takes you to read the whole thing. Now the question is, why should I read it? I mean, who cares, right? Why would I want to read the whole thing? Well, did it ever happen to you that you change something with enormous confidence only for a test to break somewhere else? Did it? Why? Is it because you were careless? Or is it because there was an information that you were not aware of? That's why. The thing is, your system changes multiple times per day in parallel to your consciousness. The other thing to know is that you cannot hold 250,000 lines of code in your head. You think you can, but you cannot. That's the problem. But think about it. If reading is the way to go from raw data to information, what are you doing? Because software isn't text, is it? Is it text?
No.
What is it?
Code.
Code. But what is code? Is it text? What is it?
Yeah.
It's data. I would argue that it's data. Okay, let me show you. I'll just give you an example. Is that okay? We talked about
Maybe knowledge.
maybe
Knowledge.
knowledge. I think it's at the basic, it's data. There is knowledge on top of it, yes. Like with any data.
And maybe code is data, and maybe it's code like Sussman and the others say.
Exactly. There's nothing new there. But I'm saying, what if we are consequential to those things? Because like if you hear them as slogan, like marketing things, it just comes from here, go there, and it didn't change the way you work, well, maybe it's not so worthwhile. So my goal here is that when you go out, you will know why it's important to start talking about how you read code, and tomorrow you will talk about how you read code. That's my goal. It's explicit goal. Okay? Okay, so let's talk about this. So here's the problem. We had a system, and we needed to refactor. In this case, it's a UI framework. And the UI framework had a theming engine. Okay, so the theming engine is like you have a widget that you can put, render it like this or render it like that. Okay, kind of like this. The problem is that we had this like theme. It was a theme class, and then we had subclasses of that theme. Right, we still have them. It turns out that this is like the largest class, and it has 1,000 methods. Okay, it's called UI theme. And It's 1,000 methods. And it's very hard to create a new theme, right? Because people have a hard time figuring out what they should override. Okay? So 1,000 methods, and the question was, so we knew that this is not good. The question is, how do we break it apart? Okay? Starting a problem, and you might have seen it in other kinds of situations when you have maybe a monolithic service, or you know, I don't know, maybe a whole system that you need to maybe break into different pieces because of various reasons. Right? Okay. So now let's see, how do we handle this? So one option, these are all the methods in that class. One option is to say, well, let's look at the internal calls, like all the self call, the local calls between this maybe. So I get 1,000 nodes in my original graph, and now I have here 800 subgraphs. It's not a good thing, right? I don't take one piece of 1,000 subpieces and I split it in 800 pieces. That's not a useful decomposition, right? So if the internal structure is not useful, what could be useful? If this is a useful way to guide us, what could be useful?
Interface.
What's with the interface?
The way that we speak to the class.
The way clients use the class, right? So if I would have a magic power and I would do like this, right? And I'd say, well, here's a client. That red thing is a client. And now I cluster around it all the things that that client is using from my class. Right? Then I can see, oh, look, that's an interesting thing. What happens if I add another one? Oh, those two clients have one method in common, but the rest are not. Right? It's interesting. Well, what about this one? That's completely isolated. So then what we did, we clustered all the clients from whatever way, and we chose like 12 relevant of them, 12 relevant clients of this thing, and we clustered them like this. So we saw very, very strong clusters, right? Look at this. Boom, 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 boom. That's great. We still have a problem. The problem is we've only clustered 50% of our original thing. Okay? So then we said, well, what if we take into account the internal structure? Now we have clustered 80% of our original class, and we still have these incredibly strong clusters here. Don't we? Right? That's interesting. What does it tell us?
That you can break it.
That I could break it right here, and maybe right here. So now I took a 1,000 data points problem, and now I transformed it into a dozen data points problem. Because I'm only interested in these joint points. Right? Because they are used both here and there. But you see how I went from, I decreased the problem 2 orders of magnitude. Does it make sense? Yeah. Now here's the thing. Does it make sense to you, like what I just described?
Yeah.
So here's the thing. You just reasoned about 50,000 lines of code, and you saw 0 lines of code.
0 what?
0 lines of code. Isn't it fascinating? The other thing is, you reasoned in minutes, and you agreed with my thesis. Why? A couple of reasons. First reason is because I told you a story. Second thing is that I made that story apparent with a couple of pictures that were handcrafted to communicate this exact story. These are not generic visualizations. They only work for this specific problem because it involved picking exact methods, looking at the specific codes, coloring in the way we wanted, clustering the clients there. We created that visualization for it to be effective. And by the way, is this not the prerequisite for doing something together? To understand, to have a level playing field, to have a common understanding of what the problem is and what the direction is, before we can start doing it. Right? This is what architecture could look like. So, how did we create that thing? This thing over here is literally created with this piece of text, piece of code here. Now, what I want you to notice is that there is no scroll bar. It's not a fake. It's because the whole exercise here took about half an hour. Right? And this exercise, we use it on a daily basis, maybe dozens of times. We build these kinds of tools continuously all the time. And what is interesting is that we focus on creating engines with which we can express these kinds of analysis that require you no scroll bar. Why? Because it's very, very important for these tools to be very cheap or very inexpensive. Why is this important? Because software is the most contextual thing we have ever created as human species, which follows that it is impossible for me to predict your exact problems. This also means that it is impossible for me to give you a clicking tool, because a clicking tool will know exactly what your problem is. But if I cannot know what your problem is, I cannot give you a clicking tool. What I can do, though, and that's the fascinating thing about being a programmer, is you happen to know how to program, right? And you actually choose to program, hopefully, Turing-complete languages. Why? Because Turing-complete languages allow you to cover any variation in the problem domain, right? It allows you to deal with that context. So it is for this reason that we're creating tools that allow you to program your way through your software. So rather than having something you click on, we give you something you can build your views through. Does it make sense? So why, right? If I can build this, right, then I can say, because here you have a query, you have visualizations, and you have various kinds of data algorithms, right? So I can tell that software is data. Because I just applied a data analysis tool on my software, and I informed an architectural decision. No? Questions so far? The software is data. Now here's the thing. What is the first, if I give you a problem in a database, right? They say, well, there is you have a database with, I don't know, 1 million records, right? With various, tables, whatever. You have 1 million records of them, and somebody tells you there's a problem there. What is the first thing you do?
I ask them what the problem is.
After you ask them what exactly the problem is.
Well,
Try
then
to understand how is the data organized.
You try to understand how is the data organized. How do you do that? How do you look at the data? You look at the structure of the database, right? Okay, what else? You write a query, right? And then you look at the data, and then maybe you write another query, and then you look at the data, and then you refine the query, and you look at the data, and then you write another query, and you look at the data, and eventually, you'll make a decision. So do you start scrolling to the database? It's fascinating, isn't it? Because when you have a problem with data, you start with the query. Now, let's look at something, because there's something interesting here. How does it, for example, you're using SQL, I guess? Okay, so how does a typical SQL tool look like? Kind of looks like this, doesn't it? You have thing, and you have here a navigation, right? The structure of the database. And then you have something on top where it says query. Then you have data. Right? So what's the first thing you do? You look here, then you write a query, then you look at the data, and then you repeat. Right? Right. If now you have a problem in your code, you find yourself scrolling a lot. Right? So why? Let's look at the tool. Same kind of thing. You have the navigation to the left, and then you have text. So what do you do when you see text? You read. You read. Because that's what people do with text.
okay, but depending on the language, maybe you've done navigate a little bit more intelligently. You can search. You can
Right.
find usages.
Right.
Find
So again,
informations.
go back to the same problem here, right? And this problem here, how long would it take one to reason about this whole thing? It wouldn't take half an hour to talk about 50,000 lines of code. Because it wouldn't. So we're talking about, is it possible to increase your productivity with an order of magnitude in this space here? And it's hands down possible. Every time you take something that you have never inspected and adapted on, and you start inspecting and adapting on it, whether this is performance, quality, whatever you want, you have an almost guaranteed possibility of an order of magnitude improvement. If you have never optimized on it. And you just told me you never talk about how you read code. And now I'm suggesting that because we're doing that, we shouldn't treat code like this. We should kind of treat it like this. And there is a fascinating thing here. And that fascinating thing is, how many of you have one of these? It's a phone, right? A phone without an antenna and without, key bindings there.
All of us.
All right. So how many of you looked at the phone within 5 minutes of waking up? No, seriously, raise your hand. Isn't it fascinating that you did that? Because 10 years ago, okay, 11 years ago, you couldn't and you didn't do that. And I know you didn't do that because the behavior didn't exist. Because there was no such phone. Isn't it? It's fascinating. Because the phone dictates how you behave. So the tools, that's why it's fascinating to see that in the latest iOS, you have this tool that tells you how much did you use the phone and how did you use it. If you don't use it, then you should update your iOS. Because it allows you
Does
to...
it work?
It does.
Okay.
And it allows you to, it gives you the prerequisite for being able to inspect and adapt. Right? Because if you never think about it, you will do what the tool tells you to do. And that's a fascinating thing. Now, if you think about software, software doesn't have a shape. Just because you're typing text doesn't make text the shape of software. Software is data. It doesn't have a shape at all. I just put it in that picture. So it clearly doesn't have one single shape. It has any shape you want. So the choice of the shape, because if I would have shown you the 50,000 lines of code here, or I show you this picture, you had a dramatically different kind of an outcome, didn't it? Right? So that means that the shape of software is critical. It's essential to software engineering. It's not something that you leave it to the side. And there's a principle there. And that principle was coined by a guy called Marshall McLuhan. And he said that we shape our tools, and thereafter, our tools shape us. So the interesting thing is the consequence of this kind of a principle. So the consequence of this, I call it the McLuhan's law. He was a philosopher in the previous century. He looked at how TV and radio were massively introduced into the American culture and how they massively changed the American culture as a consequence. So now what is interesting is to look at the consequence of this principle, this law. What the consequence of this is that we should be very picky with the kinds of tools that we expose ourselves to, because they will determine the way we're going to think. So when you will choose your IDE, you should be very careful with what kind of characteristics that IDE has, because it will dictate the way you're going to think. That's why it's worthwhile talking about how you read code, because it's not a given. And by the way, currently, all IDEs that you use are broken. You don't have to believe me, so I'll show you. So, let's see. What do we show you? So I have here's a problem that we had to deal with. And that problem is when we look at we at think stands for feel and think. We at think, we create tools and techniques for software development. And specifically, we create a new kind of an IDE, which it's called the Glamorous Toolkit. And while we worked on it, we started to say, well, how can we, because this is broken, right? Because our tools does not make us talk about our main job. And because by using the default tools, we get the wrong patterns out of our behavior. How do we change that tool? And what's the core essence in there? And what it turns out, for example, we say, well, what's the simplest tool that you have at your disposal? But the tiniest tool, what is it? The most basic tool.
Grep.
Grep. Oh, by the way, when you do grep over text, what do you do over code? What do? You basically say the code has no structure, all lines are equal, and I'm gonna use grep for it. You're throwing everything you know about code away, and then you're treating it as if it's text. Text. Wrong. Every time you use grep, you're doing something wrong. Every time you pick the scroll bar, you're doing something wrong. Because we just saw, whenever you think that you can scale the picking or the retrieval of information out of data with your eyes, you're assuming that you can scale, and you cannot scale. The problem is that data is way larger than your ability to digest it. That's not the solution. The only alternative is to teach the computer to do something for you so that you can only do the driving part. And we saw that it's possible to do it. As I just gave you an example. I have many other examples, but we only have an hour. So the most basic tool that we have, for example, in Faro, it's the inspector. Thank you very much. So the inspector is like this. Imagine this. Imagine I give you a map, a hash map, a dictionary in Java, one of these key values. So let's do this exercise. Split these in pairs, and think about this. Imagine you taking a napkin and explaining the object that you have to your colleague, the contents of the object, the contents of the dictionary to your colleague. Try to draw it on a piece of paper. Imagine that you draw it. Is this okay? Just take 2 minutes to talk about it. So let's do split in pairs, please. Two, you go there. 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 Is it understand? So you have a dictionary, right? You put a breakpoint in the debugger, and now you need to show it to your colleague. Okay?
¿Cómo le explicarías un diccionario a él? ¿Cómo lo explicarías? ¿Cómo dibujarías un diccionario?
So let's come back. So the funny thing is that it wasn't straightforward. You actually had something to talk about, didn't you? Yeah. Which is amazing, right? I just give you like a basic data structure, and it's still something to talk about as to how do you represent that data structure, isn't it? Right? So one possible representation would be something maybe like this. And then you say something, 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 right? Would this be a possible presentation? Yeah. Right? Okay. So here's the funny thing. So this thing over here is a useful presentation, you deemed it interesting for communication purposes. So if you want to communicate with somebody, you said, well, I will use this. So could you please tell me, what do you see in a normal inspector that you open today? If you open it on a dictionary or a map in Java.
No,
Usually text.
It's a,
Usually it's just text.
of what? But where, how is it presented to you? Because this is text here too. Key value, blah, 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 blah. Hmm?
Something like that.
Hmm?
Similar to that.
No, this is the code. I'm looking at the instance.
Yes,
Exactly, right. It's a tree with something.
It's a tree, isn't it?
Yeah, I think the problem is that when you inspect a dictionary, you see the internal implementation of the dictionary. So, for example, a hash value dictionary.
Exactly, isn't it fascinating? Something like this, right? And I do this, and I look at here, I see that. Here's the tally, here's the array, and so on, right? All inspectors in the world show you that. And you're telling me that this is a much more useful way of presenting the data. Do you think that this is an expensive way to present that data? No, it isn't. It's 3 lines of code, literally. Really, it's really, really stupid. Stupidly cheap to do this. So why is it that all tools in the world show you a tree? Because they solved the wrong problem. As you said, all inspectors in the world, except of one. All of them describe their utility as being the tools that show you the interior of the object. Let's flip this around and say, I want a tool that helps me understand an object. Not to show me its details, but to understand the object. Just this little tiny design though. Right? Let's see what this means. Let's see what this happens. So it happens, then all of a sudden, for example, here I can see a table. No? Or it happens also that if I, for example, here's a string with 42 as a string, and here's a number which is 42. So if I click on string, I might see that string as being a collection of characters, or I might see it as being the actual string without the quotes. Right? So this is an object, and I'm seeing here multiple different presentations, multiple different views for that object. Okay? So because there is no single point of view, the internal implementation is still relevant. Also of the dictionary, also of the byte string, it is still relevant. But who cares about the internal representation of the dictionary? Well, I tell you, the guy that implements dictionary, the algorithm, the compiler person probably, and the VM person. All the rest of 99% of the population does not care about what's inside. But it still doesn't make this one an irrelevant point of view. It is a relevant point of view, except it's not the most useful thing. Other points of views are also interesting. And because software is data, it follows that there are many different shapes of that data. Right? Okay? So how do we then change this? So what else can we do with it? So here's a number. Okay, a number is 42, it's fine, but it's an integer. And if it's an integer, maybe I can want to see how it is different, spelled in different spaces, right? Why not? Is this useful for everybody? No. But is it a meaningful representation? Yes. Right? So you never know, but you don't have to just pick one, because there can be many. Right? What about the date? Well, the date, for example, I might want to look at it like this. Here's the year, the month, name, all sorts of other things, right? Or maybe I want to look at it like this. Because why not? Any presentation is interesting. Did you feel something when I showed you that? Was it somewhere here, right? Wasn't it here? No, seriously, wasn't it here? That's why our company is called Think. It comes from feel and think. We have spent 50 years in this business thinking. And I think we forgot to feel. And it's because we have not paid attention to how we feel that we ended up hating our job. We have the coolest job on the planet. We should start paying attention to that. Because when you have the coolest job on the planet, you don't just have the coolest job on the planet, you also happen to have a very interesting responsibility. Because, you know, our kids will only know a world of software. And we are building it now. You're right now building everything in the future. That's a huge responsibility. The problem is, unhappy people are unlikely to produce happy results. We have to change that. So that feeling that you just felt when I showed you this, that's important. And I want you to go and look for it, because now you know that it exists. If somebody tells you that it exists, you don't believe them, but now you felt it. So now you can go look for it in your environment because you know that it exists. Okay? That's why it's worth talking about how you read code. So, let's not be that serious. Let's see, what else can we do with this? So here's a funny thing. Here's world, right? In Faro, you know, you have a graphical framework. This is the old thing. So here's an interesting thing. Let's maybe start another window here. Here's a debugger, right? That's how debugger. Debuggers are not scary things. You should love them, right? They're there. Don't close them when they open. Learn from them, right?
No,
This is
why
a
not?
place.
I look at the log.
Exactly,
If I
the
look at
log file,
I
print
use a
string.
debugger.
Put a print string in there, and then throw the debugger away. Okay, good. So now here's a problem. Everybody asks me this question. That question is, what kind of key bindings are available in this text editor? That's a relevant question, right? You want to use a new framework, a new tool. What do, right? What key bindings are there? And it's one of those things where Stack Overflow shines, right? Because you take this problem, you put it in Google, right? You press enter, the first thing you hope, it's a Stack Overflow answer, right? That will point you to where the manual is. Then you will go read that one, and then you will come back to your tool. Now, by the way, what does I in the IDE stands for? Integrated. That means every time you leave your IDE, the I has just failed you. That's what it means, right? Okay, so what is the alternative? So let's see. Well, this is somewhere in my graphical tree. So let's inspect that graphical tree. So world gives me everything. So it looks like this, right? That's the morph, right? And it has submorphs, those sub-elements. So it's somewhere there. Now I know it's here because it has this red border. So let's quickly check this. When I'm clicking on that one, and I'm looking at the morph, right? Now I can see the preview of it. So let's navigate a little bit and find our thing. Well, it's not here. Well, that's the top bar, right? Right? Well, it's somewhere there. Well, it's not this one because that's my top list with stack. Oh, it must be in there. It's there somewhere. Oh, yeah, it's definitely there. Still there. And maybe I go a step further. Oh, something happened here. A new tab appeared. You see? There are keys defined there. What's that? I don't know. Oh, look, there's a table. A table of keys. So meta plus L means self-action presentation. Let me see it again. Or maybe Q. It's like target editor query symbol. I would love to see it in the code. Because it would be like, that's where the documentation is, isn't it? So what happens if I click on this? Well, that happens to be an object, which is a key map. It holds a block. The block knows the source code. And because it knows the source code, the key map knows the source code. So now, what do I have? I don't just have a browser that tells me what my key bindings are. I have the exact specification of what the key bindings does. I don't have to necessarily believe the label of the button if I don't want to. So what is the inspector, by the way? Remember, this is like the most basic tool you have in your environment, right? But wasn't it supposed to be just for objects and code was supposed to be somewhere else? No. No, it doesn't have to be like this, right? And in the same environment where I looked at dictionary, just by flipping things around and creating different small custom presentations, I now handle a whole completely different kind of a use case. Well, maybe let's do something that is maybe more close to what you know. How about Postgres? So here's I have a Postgres client that I open on a database. Oh no, I don't have the right. Just a second. I need to load them. So I'm now loading the extension that is specific for that environment. And when I'm executing that, I get a new tab because this is a connection to a database. I get a tab. In this case, I already populated with the query. And in this case, it's a query that goes over the database and gets me cities and population and the continents. Okay? And what is that result? Well, it's a table. So I present it as a table.
Okay.
Now, let's say that I'm interested in find out how the top cities are distributed over continents. I want to see top 20 cities, for example, and how, which is in which continent. I could do a query, couldn't I? I could? Yes, I could. But it would be boring. And that thing that I feel over here, it matters to me. And now that I just won 10x here, I can do whatever I want with my budget. Right? I can invest it in my happiness. So what will make me happy? What will make me happy, or at least happier, would be something like this. I want to see a chart. So first, let's say I want to get this data, this 20 things, right? And I will see these ones, right? These are the entries, excellent. And then I will build a real chart here. And I already pre-made it so that I don't have to type it now. And it has like these bars, right? So this is Mumbai, and then Seoul, and Sao Paulo. There's no Buenos Aires. But I still don't answer my question. My question was how they are distributed across continents. So let's write one more line of code. And now I associated a random color to the continent value, right? So now maybe I don't know because, I'm a computer scientist. What do I know about geography? And I don't want to, use Google. So I want to find out what is blue. And now here's the thing. This is data, right? That's not a picture. It's a representation of data as a picture, which means that if I click on that bar, I will get the data behind it. Right? So that's the funny thing, because now I know it's South America that's associated with blue. So what did I just do over here? What I did was the following thing. So we start with a hypothesis. Right? I think it's with a Y. No, it's with an I. We start with the hypothesis, and then we apply an analysis. And then we interpret. And after we interpret, if we're confident, we act. We do, we die. Right? And if we're not, we're trying it again. There's a funny thing that happens between here and here. By the way, anybody knows what this is? Start with a hypothesis, like an analysis, experiment, whatever, measure.
Scientific method.
Scientific method. It's now popularized by the lean thinking. But it has been there for a couple of centuries. It works reasonably well. We might as well use it. There is one tiny problem. And this the problem is the following. For whatever problem you have, there might not be a tool available. So what do?
You
have to craft your tool. This is a very important thing here. You first ask yourself if the analysis exists. And you apply it. And if it doesn't, and that's the key, if it doesn't exist, you will craft it. And then you will apply it. Right? That's what we just did there. We had a problem, We looked at it, oh, is it like this? Is it like that? Oh, I don't have the right tool. And then I will build it, and then I will continue to do it. It's very, very important to have this. Why? Because if you do not use this, if you do not build the analysis, you will use your eyes to do the reasoning, or to grab the information. Why? Because the reading and your eyes are the most malleable tools you have at your disposal. They can deal with any piece of text. They just happen to be inaccurate and very slow. That's the problem. And you have to make decisions, dozens of them per day. You are in a decision-making business. You're not in a construction business. That's a different point of view. And you should look at tools differently because of that. So, questions so far? Do we stop or do we continue a little bit? Because for the last 3 years, what I showed you here, this is a technology that we built. It's called Moose. And then there's a new project which is called the Glamorous Toolkit. And then over the last 3 years, we have built the next generation of that Glamorous Toolkit. So if you would have a bit more time, then we could show you that, or otherwise we just stop now.
¿Tenemos tiempo? Si no, se puede quedar.
No, seriously, we can just go if you want.
Continue. Okay.
We continue?
Yeah. Some people have to leave. But
Yeah. Great. So let's show a little bit about this new thing.
Awesome job.
Right.
Thank you very much.
So in the new environment is very similar. So it has this idea of moldability at its core. And that idea is that we need to make the cost of crafting new tools as low as possible. And in our case, they are measured in millions. So the cost of all of those little tabs that you saw in the previous environment, they were less than 10 lines of code on average. And we have thousands of them. Okay? That's how different this thing could be. So let's see how it could look like differently in another world. So here's, for example, here's an environment that allows us to look at the file reference. Like I'm just looking at the folder locally. And notice how these things are slightly differently arranged. So when I look at one, maybe I can look at that. And this is a zip inside, so I can see inside that zip, and this is a JSON inside. I can see that JSON, right? It just happened in the same inspector, right? I just navigated through different kinds of files. Okay, what else can we do with it? Well, one of the things that we said that we want to change was not just how we inspect objects, but because we learned that this is so important how we look at objects, the shape of an individual object, that shape, we want to be able to control that shape, then we said, what is the next level? And so when we talk about integrated, we said, well, what if we can go a step beyond developers? What if the IDE would be a tool, not just for technical people, but for product managers as well, for example, or for technical managers? How would that be? And I said, well, what is a common language there? Because you see, by default, this kind of IDEs, they already start with the assumption that somebody wants to read code, right? But if you don't read code, by the way, in our case, the code was at the end of the navigation path. Right? Only after you know why you want to read that piece of code, only then do you read it, not before. So, so a different way to look at this, when we say, well, one thing that unifies people is documentation, like documents, right? Confluence pages, Word documents, you know those? And they're being sent around the Word. I love it when the people send them around by email, right? With things inside, but there seems to be like a common denominator there. So here's a different way of looking at documentation. So this is actually documentation of the Glamorous Toolkit. And you see here, this is written in a kind of a markup language. It's the original wiki syntax, and this is a live editor. So when you type something there, it actually renders. Or here, for example, I have an example that I just embedded right in place. And when I say I embedded right in place, is that if, for example, if I delete that thing and I add it back, I get the picture here, right? It's in the editor. It's live. As I type, the picture gets added. So it's kind of a notebook. Anybody knows Jupyter notebooks, for example? Notebooks, those live data notebooks, right? People in Python, they kind of knows them. So this one is like that, only it's significantly better in that it is live and it is debuggable because it's already part of the IDE. Okay, so here's, for example, a whole inspector embedded inside the document that I can just play with, and I can go and investigate this if I want to. So I can double click and I can see it there. Or maybe I will look at them at various kinds of tutorials. So here's, for example, a tutorial of one of the graphical engines that we have. In this one, for example, it shows you, oh, here's how you build this kind of. Oh, that's not good. This is how you build. This is how you build that tree. And then here's a class hierarchy, and the script above was the one that produced the class hierarchy. So let's see how the tutorial looks like. So first of all, you create nodes, right? Oh, but before you create the nodes, you have to instantiate the view. It says here, well, self-empty view. So that's a call to another example, right? This is an example that we have here. Anybody's using test-driven development? Who's not using test-driven development? Herman is in the room.
I don't use it to write emails.
Oh, I see, to write emails. Very good. So example-driven development is the natural evolution of test-driven development. Everybody will want to do it, but next year. So you get to see this here. Anyway, so you see here, self-empty view, that's another example. So when I look at this one, I can just embed and preview the code right in place because that's what you would like to do. Did you feel something here? Right? Think about it, because it's really, really important, right?
Why should I do that if I can open a new edit?
Exactly. I don't know. Exactly. Everybody should be able to open just another editor, another window, just so that we have what to do. Because otherwise,
and we can lose, what you're thinking about.
Exactly. So here I have the nodes, and I create two nodes, and I put them here. It's like it's a Fluent API, and this is the result, right? And then I get those two nodes, right? The code that you saw before. And then I add edges, and then I get this. Oops, I get this. Right? 1, 2 nodes, and then an edge in between them. And then if I have those edges, I can lay them as a tree. And now it's one below the other. And then if I have something else, like for example, here's a grid layout, and then here I can take the same grid layout and then I make them a tree out of that. Now this is documentation, but here's the funny thing. This documentation is live. The second thing is, even if it contains code, that code is not here. It's embedded here. The code lives where it is tested, not in the documentation. This code, as long as all tests are green or all examples are green, will always work. This is how you write documentation. So in fact, the whole text that you saw there is this large. It's not that large in terms of text. But if you look at how much you can do with it, right? You can have this, you can have that with nested things inside, or that you can have here, this is static analysis of different packages and things internally inside those packages, or this is how you embed whole text editors in there. Right, so actually this is a whole editor there. So you can actually click there and then start doing things, right? Scroll. This is another one over there. But then we can take it a step further and says, well, here's a whole new graphical. So in order to produce this, we actually created a whole new graphical stack. Over the last 3 years, we started with a completely empty canvas and built a whole new graphical stack. Now, people say, what does it mean to be a graphical stack? Right? What's so special about? Why did you have to? Why could you not take something that existed? Well, we couldn't. So here's why, and this is a document that explains why is this a special stack. So this one, for example, it says, well, first of all, it's a one rendering tree. That's hard a little bit to express maybe, So here's here's an example of what do we mean by that. And one of the things there is that the editor is made out of arbitrary elements, or not arbitrary, regular elements, right? And you just apply a layout over that, which means that I can embed, for example, that red rectangle anywhere I want, at any time I want in the editor, which is a funny thing to have. So what does it mean? So here at the bottom, right, we have here an editor, and this editor here, this is its internal representation. Right, so you have this whole element, that is the first line with the blue thing, and then there's the second line with the red thing. The second line has the red thing over there, and notice how this one is just part of the same tree as everything else. Right? And every word is an element. So I build a tool, in order to express why is it interesting in this thing, I build a tool to show you that. I don't have to draw anything on a whiteboard. This is right there, it's a live documentation as to why this is true. And now you don't have to believe me that this is really true. So what if I click here? So what happens is, if I click here, there is a cursor that appears here, right below that element. And the cursor is an element too, right? And I can also do this. And now I have 3 lines. And those 3 lines, right? Let's see, 1, 2, and the 3 lines. That's right there in the documentation. How do you feel? Because, like, look, the one thing that people don't necessarily realize is that we are inventing a different way of programming. So, you know, if I would have told you this at the beginning of the talk, maybe you would have thought I'm crazy. But the more I talk about it, the more I convince myself that we are not crazy. But it's really ridiculous how I feel really strange to show these things, because we are surprising ourselves all the time with the length at which we can go to express things that otherwise were really difficult to express. So, and it all started because we started to question exactly that problem. How do we not read code? Anyway, so there are all sorts of other things inside. So for example, one of the principles is that this is debuggable. So here you have an element, and if this element that you have over here, right, I can look at it like this, right? I can see, for example, here all the different metrics. Is something that you will see in a normal, but you don't see in any other graphical frame. So apparently, the padding and the margin are only relevant for HTML elements. It doesn't make any sense to me. Why don't all graphical tools already ship with those things? I don't know. It's a mystery. Yeah. So, but we can go tiny bit step further. And here's a tiny bit step further, because what I said here was, queries. If the query box was large, people started to write a query, right? So what if we make queries pervasive everywhere? So you see, we have this playground, the initial place where you can just type any piece of code. And let's say every one of those tabs that you saw, right? They are defined with an annotation called GTView. So let's quickly find out what are all those views, right? So now I get here a list of all those extensions. It's a lot of extensions. Okay? We can quickly find out how many there are.
I want to see the code of one. Can I?
No, it doesn't have size. Okay. Can you, if you want to see the code of one?
Yeah, one extension.
Like this one?
Oh.
Yeah. Right? Or maybe like this, because maybe you want to see 2 at a time. But here's the funny thing. Let's say that we're interested. You see, here this is a list, and this is called explicit. There are 2 different kinds of presentations. One shows you a list, the other one shows you whatever you say inside here. So I really want to find out what are all those lists are using. What kind of API are those lists are using? Because somebody mentioned here, I sometimes want to learn an API, right? So now I say, well, you want to learn how to create a new extension, and the best way to learn is from examples. So first we need to find those examples. Now that I wrote that query, I know, right? I'm looking for those things that are annotated with GTView and that are sending list, are sending this message. That's a code query, right? So if I now look at this one, here's the funny thing. This code editor knows both to underline this and this. Right? So with normal clicking tools, you can do this. You can't do this, by the way. You can do this, you could do this too, but you could not do the combination. And specifically for my problem, that's the interesting list, not the previous one. And if I would have just looked for all the lists, then I would have got way too many results because there were other usages of lists. Right? And notice how now my code browser, or sorry, my inspector actually becomes a code browser. Because why not? I can go and change it. And this is all live. So if I, for example, go and delete this, I can do it. It's right there. It's live. And by the way, now this will be a syntax highlighting. So now it tells me, oh, you have an exception. Right? There's a token unexpected. Because I missed something here. But this is not embedded there for those that know Smalltalk. It's actually just a note. So if I type over it, it goes away. Right? And a similar thing might happen here. Let's say if I have an exception here, and I do it, I get the 0 divide. And if I don't do anything, it disappears, because I don't need that, right? But if I really want to debug, then I click on this one, and then I debug. But only then do I debug, not before, right? But one thing that I noticed when I said before is this one. So I have here an example, and if I run that example, I get this. Simple example. I'll just show you this one, and then we stop. So this example basically is a yellow thing, and notice how this one is made of an element that in the end is an empty element, right? But it's a little bit complicated because this one is also using an element, and this one is also using an element. It's kind of a bit of a long. And I don't quite understand which one of these actually map to which one of those, right? This is a real example from our library that describes the layouts. In this case, the flow layout. So let's look at the same thing, but slightly different. So let's maximize this one a bit and look at the connections. So this is the same example, but now zoomed out. Notice the scalable interface. So you notice here there's a button here, yellow, right? And that button, by the way, appears and disappears based on how we type things. So the syntax highlighting adds stuff into my text, because why not? In this case, it's actually a button. So if I click on it, it gets me there, right? And I can see now what is that example. And I click on that one, and I see that example. Now, what happens if I scroll here? Let's see. Do you feel it? Now here's why you feel it. Because this kind of behavior you don't have in any other editor. So this, in order for us to be able to draw a line that sticks to that thing inside the text editor, we need this whole scene to be made of the same thing. Right? Not something that is here, text editor world, and the other world in between. That's why we can have a line that goes from here to there, right? So let's see. Let's do some more of those, right? So maybe red. And this is not, as I said, this is not made up and made an example. It's a real documentation of our layout, right? So maybe I can make them like this. Now here's the thing. Because each of them is an object, or is a code that returns an object, I can inspect that, right? And here I can see, oh, this is an empty object. An empty element, and this is going to be a yellow one, and this is going to be a green one, and this is going to be a red one, and this is going to be a blue one, and this is going to be that. Thank you.
Are you done?
I can go on forever like this, but I'd say let's maybe you have questions or so.
Yeah, bueno. Questions? So the graphical framework is the Glamorous.
No, Glamorous Toolkit is the IDE, but it sits on top of something which is called Block. It's more elaborate.
So, but you don't have a separate version or something for the visual framework.
Of course.
You have it separately.
Yeah. So the stack is looks like this at the moment. So it's called. We have here the Glamorous Toolkit. Then there is a widget library which is called Brick. Then there is the graphical, basic graphical framework, which is called block. Then there is a new canvas, which is a graphical vector graphic canvas, which is called Sparta. And then the rendering is actually done based on an external library, which is called Most2D. So each of these are individual projects.
Okay, and you get rid of more.
Yeah, this is a whole new world that has nothing to do with morphing. Everything that you see here, everything you see inside this window, everything is nothing to do with morphing. So just to show what we mean by that, maybe, but we can talk. So here's, for example, the same thing open in a native window with no morphic at all. And this one has real, so for example, here, if I click on one of these, right, I get those things. So this one has no binding, nothing to do with morphing.
And there is an image or something.
If you go
to for that.
Yeah, if you go to think.com/gt, you will find the Glamorous Toolkit, and there's an install section. It's based on Faro 7.0, the latest Faro, but basically it's a whole different, it's a new world.
I guess my first idea I have about that is, I don't know how simple is it, but about doing the thing I'm thinking about, about to start to educate kids, or just to start kids with programming stuff about doing that, because if they can think about an idea, then go to the idea about making code and all that, and maybe educate people or educate just young people with that.
Sure.
I feel that it will be very intuitive.
Absolutely.
Maybe because I think that maybe I feel that when you, I feel it's very impressive the way you go from the documentation and the code and go ahead back. It's very interesting, but I feel about the education that it will be useful also.
Yeah, but it also changes the way you program. So the way I program now is fundamentally different than I programmed 5 years ago.
Yes, I guess.
So, but like, I don't think in the same terms. So if somebody puts me in front of a typical tool that developers use today, I feel like I'm unable to do my job. So, but yeah, education is definitely an important point. Yeah, I agree.
It's maybe a tricky question, but
Yeah, don't worry.
how about accessibility?
About what?
Accessibility
What about it?
for blind people, things like that.
That's an exciting problem that we're just talking during.
He's one of the.
Yeah, that's really exciting, because if you think about it, and then you were working on, if I understood correctly, the Lazaro system, right? Which is, for those that don't know, is basically showing you the IDE, or for example, in that case, Smalltalk, or some Smalltalk. I think it was, I don't know, Faro, was it? Okay. And then it would speak to you what is on that screen, right? Which is an amazing thing. I didn't necessarily think about it before. But then the question is, how do you present that information in different ways that makes it more interesting for the person that doesn't see, right? And especially if you think about it, because there's a lot in the default Faro GUI, right? There's a lot of not interesting things. They are not about what you're actually looking at. Right? I'm not interested that I'm in the category Spain. I'm just interested what is the method that I'm looking at. And if I can say that I'm looking for those kinds of methods in that kind of thing, all of a sudden it's just like in that class, and I'm looking for this method. And it's a different way. You can specify the interface in a different way, right? So it's exactly the moldability part of it. And by the way, I didn't talk about search. So if you think about, how do you find a method? So here's, for example, this is our environment. This is in the default Faro. It's called Spotter. So our environment, not only our objects, not only tell you how they can be presented, they also tell you how they can be searched, which can be directly interesting for people with disabilities, right? Because why do they have to necessarily tell you here's the widget? It can also tell you here's a vocal presentation of me, right? Why not? It's the same principle, and it applies. It applies there as well. So for example, here, if I want to look at object, and maybe here I'm going inside, now I'm looking for print on, right? And then if I go inside the print on, I will look at implementers. And maybe I'm just interested in the implementers in collection, right? And this is how I'm searching. And if I look at that one, then I'm looking at maybe at the senders or something. Or let's say I was doing this thing that I showed before, right? Where they say, well, what if I'm looking for the pragmas that is called GTView? Right? So if I look at this one, then I can see where it is. Right? So it's a different way. It's like you can mold the search part equally well as you can mold the inspection, for example. We can do the same thing for debuggers, for example. You can switch debuggers at runtime depending on what is on the stack. Because why not? Other questions? Yes.
So, how difficult would be to a programmer that is used to use text or editors, right? Go start thinking this way. How do you think about it? How much it's going to take them? Is it possible for them to change the way they think?
Yeah. So there are a couple of different things, and there are different layers, let's say, of applicability. This thing over here, this is called humane assessment, and that's a method that I created 9 years ago and validating ever since in industry. So if you go to humane-assessment.com, what you will find out there is, so there's a quite elaborate description of what the method is. What you find out is that you actually have two kinds of roles in humane assessment. So this is humane assessment over here. So this one over here is the facilitator. No, sorry, this is the stakeholder. The stakeholder is the one that knows how to ask the question, pick the relevant question, and make the decision. And that one is not the same as the facilitator. The facilitator is the one that understands the tool. The tool, they don't have to be the same person. In fact, it's better if they're not the same person. Right? There are two distinct roles. It's not that this is a job and this is a job. It's more that these are roles. It works very well in pair because you need to go to different, this is a meta level, and this is the interesting problem level. Right? So it works much better if you have two brains to deal with those. So this one is the technologist. Right? It's the one that knows how to do it. It's very similar to, let's say, sysadmin developer. Right? You know what you want, you just don't know how to do it. Or maybe you even know how to do it, but you want somebody else to do it.
I would put it the other way around.
Whatever, right? I'm saying you need a service of, set me up this database, right? That's a service. This facility is always a support for the stakeholder. Okay? Now, this is the easiest to teach. It takes about a month of effort if you do this. Right? If you take, for example, Moose or start working around Moose, because that's one that's the most applicable for your other kinds of languages, doesn't have to be thorough as a code. It takes a month of work, of effort, to be fluent in this. But the most difficult and most interesting is to change this. Because this is the behavior that it's already ingrained. You don't question those things. It's the moment you pick the scroll bar that you should ask yourself, is this the right thing to do? Right? And if it's not, then you should go and ask, oh, can we build a tool? Right? And then, of course, whether you build a tool or not depends on how much the tool costs. The more you invest here, the less the cost decreases. The more the cost decreases. And the more practical this workflow is. Right? Now, the question is, where do you apply it? One area that is directly applicable, you can start tomorrow, and within a month, you get your you get added value within that. If you do it consistently, is steering agile architecture. I hear you're doing some agile whatever, right? So the question is, how do you marry this idea that anybody can do anything, and yet you still want a cohesive system at the end? If you turn that thing into contracts that you build, so every time you institute a rule, you don't put it in Confluence or you don't put it in I don't know where on Slack, you put it in a tool that will check it for you, right? And then you agree, you talk with everybody in the team to see if this is the meaningful outcome or not, right? And you put this one in place, and then you can start doing steering agile architecture incredibly effectively. This is the cheapest, lowest hanging fruit you can get. And once you start doing this, you can do something else afterwards. Other questions? But just a final remark. The one goal that I set myself at the beginning of the talk was for you to start talking about how you read code. Because then you might find solutions for how not to read code. And you still do better decisions for it. My goal here was not, it's not a sales pitch. I don't want you to go and necessarily use these tools. The problem with these tools is that they're highly addictive. Right? So if you start using it once, well, it's your choice. So you don't have to use those tools. But I do challenge you to start talking about how you read code, because you will find alternatives right around you. They're everywhere, but you just have to start looking for them. And you have not noticed them because you have never talked about how you spend the largest chunk of your budget. Thanks.
Okay, thank you, Tudor. Now we're going to have a ping-pong, una reunión con él directamente. Si alguien quiere quedarse, charlar de algo en especial, puede seguir, ¿sí? Se queda un tiempo más acá, así que... ¿It's okay?
Yeah, sure.
Después de 5 minutos, 5 minutes of rest for him, and then we can shoot.
Thank you very much.
Thank you.